My dear student, so today I'm going to show you what are the all geometric theorems related to grade 10, right? First we see, so what are the all geometrical theorems related to grade 10? I'm quickly moving to the theorems, right? So I'm going to recap all the geometrical theorems related to grade 10, right? Just quickly move to the session, right? Look at this one. So if you are taking an angle like that, so we can take vertically opposite angles are equal. This one equals to x, so this one also x. If this one equals to y, vertically opposite angles are equal. This one equals to y. So we need to write down the theorem within brackets. So what is the theorem? Vertically opposite angles, right? Vertically opposite angles. Vertically opposite angles are equal. Vertically opposite angles are equal. That is the theorem. Look at the second theorem. Angles on a straight line, right? Look at this one. I'm taking this one equals to A and this one equals to B. Second theorem, A plus B equals to 180. A plus B equals to 180 angles, right? A plus B equals to 180. It doesn't matter, you can take 3 angles or 4 angles or 5 angles. So whatever the angles on a straight line, add up to 180. Angles on a straight line. So angles on a straight line add up to 180. So therefore, A plus B should be equals to 180. Let's quickly move to the third one. Angles around the point. Angles around the point. So angles around the point. So we can take, I'm taking X, Y, and Z. X, Y, Z. So X plus Y plus Z equals to X plus Y plus Z equals to, how many degrees are there? X plus Y plus Z equals to 360 degrees. 360 degrees. Angles around the point. Angles around the point. 360 degrees. Angles around the point. So 360 degrees is the angle, right? Angles on a parallel line. So what are the angles on a parallel line? Alternate angles, allied angles, corresponding angles. Alternate angles are equal. Look at this one. Alternate angles are equal. Z angles. Alternate angles are equal. Z angles. Corresponding angles are equal. I'm going to mark corresponding angles in pink color. Corresponding angles are equal. Corresponding angles are equal. Corresponding angles are equal. Right? Corresponding angles are equal. Letter F. Those angles are equal. Allied angles add up to 180. Allied angle means addition of these two angles. Addition of these two angles should be equals to 180. Total value of these two angles should be equals to 180. So that is the fourth theorem. Angles between parallel lines, vertically opposite angles are equal. Angles on a straight line, angles around the point equals to 360. Alternate angles, allied angles. What is the other one? Corresponding angles, right? Let's quickly move to the next one. Before move to the next one, let's quickly recap the knowledge. So what are the angles on theory number 4? Quickly. Look at the first one. Alternate angles. Alternate angles means Z angle. So that means Z angles are equal, right? Let's see quickly. Let's move to the Z angles. Look at this one. These two angles are equal. Z angles are equal. These two angles are equal. So what is the name of that angle? Alternate angles are equal. Alternate angle means Z angle. Alternate angle means Z angles, right? Alternate angles are equal. Alternate angles are equal. So let's quickly move to the second theorem. Corresponding angle. Corresponding angles means this one equals to this one, right? These two angles are equal. These two angles are equal, right? These two angles are equal. So that means letter F, 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 F. Corresponding angle. Corresponding angle. Third one, allied angle. So allied angle means A, B, C, D. Allied angles means that your allied angles are supplementary. So that means A plus B equals to 180. C plus D equals to 180. Allied angles. Allied angles are supplementary. So those are the three angles related to the parallel lines. Okay? Right. So I'm quickly moving to the next theorem. Look at the theorem number 5. 60, 60. Lamai, look at this one. Alternate angles are equal. Converse of the previous theorem, right? If those two lines are parallel, alternate angles are equal. If alternate angles are equal, so we can say those two lines are parallel. Those two lines are parallel. If alternate angles are equal, those two lines are parallel. Look at this one. Corresponding angles are equal. Corresponding angles are equal means those two lines are parallel. Those two lines are parallel. Converse of the theorem 4, right? Those two lines are parallel, right? So what is the theorem? If alternate or corresponding, if alternate or corresponding angles are equal, if alternate or corresponding angles are equal, that means those two lines are parallel, right? Lines are parallel. Converse of the previous theorem. So that is the converse of the previous theorem. Theorem number 5, right? So we can quickly move to the next theorem. So that one is very easy. Triangle congruence. So let's see what are the congruent stages, and let's quickly move to that theorem. Theorem number 6. Congruent stages. Right, look at this one, Lamai. So I have 4 pair of angles, triangles, right? So that means 8 triangles are there. Look at this one. What are the congruent stages? First one, S, S, S. So that means in a triangle, 3 sides are equals to other triangle. 1, 2, 3. So you can clearly see that one. AB equals to PR, BC equals to PQ, AC equals to QR, right? Those 3 sides are equal. So 3 sides are equals to other particular sides means those 2 triangles are congruent. ABC triangle congruent to PQR triangle. What is the stage? S, S, S. Right? Triangles means so S, 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 those triangles are congruent. Right? Number second stage, if two sides and included angle, if two sides and included angle equals to 2 sides and included angle, so those angles should be included angle. two sides and included angle. Therefore, these two triangles are congruent under the SAS, SAS category. DEF triangle congruent to IJK triangle. So what is the reason? SAS category. Side angle side. Third one, angle side. So that means two angles. This one equals to this one. So this angle equals to this one. And the particular corresponding side. Two angle, particular corresponding side, right? So that means two angles, angle side. So those two triangles are congruent under the angle side. So that means AAS. Element, look at this one. Element triangle congruent to XYZ. XYZ, for the reason AAS. Last one. So last stage we can apply for only the right angle triangle. Right angle triangle means 90 degree should be there. So if you can see the 90 degree, so we can write down RHS. RHS means right, look at this one. So that means hypo and the other side, right? So what is the hypo? Opposite side of the 90 degrees, the hypo. Hypo should be equal. Hypo should be equal, and another side, any other side. Hypo and any other side. So those two triangles are congruent. STU triangle congruent to VWX triangle. What is the stage? RHS. What is the congruency stage? RHS. So how many congruency stages are there? 4 stages. SSS, side angle side, two sides and the included angle side, and hypo and a side. Right. Theorem number 7, 8 and 9 patio. So that means, look at this one. Angles in a triangle, A plus B plus C. Angles in a triangle. So you know the theorem, right? Angles in a triangle, A plus B plus C equals to 180. Angles in a triangle. So I'll write down the theorem. Angles in a triangle. Right? Angles in a triangle. Look at the theorem number 8. In a triangle, if two sides are equal. In a triangle, if those two sides are equal, opposite angles also equal. So what is the opposite angles to this one? This one equals to these two angles are equal, right? So what is the theorem? Opposite sides are equal, right? Opposite sides are equal. Opposite sides are equal. If those two are equal, so that means opposite angles also equal. Theorem number 9. So that one is really important. Exterior angle equals to sum of interior opposite angle. Just think this one equals to A, this one equals to B. So what is the value of this angle? A plus B. So what is the value of this angle? A plus B. Right? A plus B is the value of this angle. Right? I will tell you the example. So this one equals to 30. This one equals to 90. 30 plus 90. So this angle equals to 30 plus 90, 120 degrees. 120 degrees is the exterior angle. Exterior angle equals to total addition of interior opposite angles. So that means I'll write down the theorem. Exterior angle theorem. Exterior angle theorem. Exterior angle theorem. Right? Theorem number 9. Wait a minute. Lamai. Angles in a triangle add up to 180. You know that one, right? Angles in a triangle add up to 180. Angles in a triangle, so add up to 180. Angles in a quadrilateral, angles in a quadrilateral, add up to 360. So total value of the interior angles in a quadrilateral equals to 360. What about the pentagon? 1, 2, 3, 4, 5. Pentagon. So addition of these 5 angles should be equals to 540. What about the hexagon? Right? So what about the hexagon? Just consider the hexagon. So addition of these 6 angles, should be equals to 720. Better to reminder those values for the O levels and the grade 10, 180, 360, 540, 720. So you need to remember those values. If you can remember those values, so they will be very easy for you. Right? Okay, video. Then I'm quickly moving to the next one. Right. So what is the equation? Have you remembered the equation? You already learned that one in the grade 9. What is the equation? Sum of the interior angle of a polygon. Sum of the interior angle of a polygon equals to 180 multiplied by n minus 2. N means number of sides. N means number of sides, right? N means number of sides. As an example, for the triangle, how many sides are there? 3 sides are there. 3 minus 2, 1. 180 multiplied by 1, 180. How many sides are there? 4 sides. 4 minus 2, 2. 180 multiplied by 2, 360. Right? Any polygon, exterior angles add up to, right? Any polygon. Look at the theorem number. What is the theorem number? 8, 9, and this one is the theorem number 10, right? Look at this one, 10th one. So this is the 10th one. Addition, so total value of the angles inside the polygon equals to 180 multiplied by n minus 2, n equals to number of sides of the polygon. Exterior angle, sum of the exterior angles are equals to 360. That is a fixed number, right? So that is a fixed number, sum of the exterior angles in a polygon, right? Exterior angles equals to 360. Exterior angles add up to 360. That is a fixed one. Okay, video. So theory number 10. So today is very important. I'm going to recap all the theorems. Right? Let's quickly move to the theorems related to parallelograms. Right. Related to parallelograms. Right. Look at this one. So what are the theorems related to parallelograms? Let's quickly move to the first theorem related to parallelograms. I'm taking this one as A, B, C, D. This is the first theorem. In a parallelogram, opposite sides are equal. In a parallelogram, opposite sides are equal. Look at this one. In a parallelogram, opposite sides are equal. AB equals to BC. AD equals to BC. In a parallelogram, opposite sides are equal. Not only that, in a parallelogram, opposite sides are parallel, right? In a parallelogram, opposite sides are parallel. In a parallelogram, opposite sides are parallel and equal, right? Opposite sides are equal, right? Opposite sides are parallel, right? So you know that one. Opposite sides are parallel. Opposite angles are equal. So A, B, C, D, opposite angles are equal. This one equals to this one. These two angles are equal. That means BAD equals to BCD. BAD equals to BCD. ADC equals to CBA. Opposite sides are equal, opposite sides are parallel, and opposite angles are equal. Right? Look at this one. Opposite sides are equal, opposite angles are equal, opposite sides are parallel. Right? So that is the second one. Right? Let's quickly move to the next one. Right? So what is the third theorem? In a parallelogram, right, the area of the parallelogram bisect by each diagonal. So that means this is the diagonal now, right? A, B, C, D. Look at this one, A, B, C, D. So I'm going to draw this diagonal. Just a minute. This is the diagonal, right? So that means ABC, area ABC equals to ADC. ADC, right? So area ABC equals to then ADC. So that means area bisect by the diagonal. Area bisect by the diagonal. So that means now if you're going to draw the diagonal through the parallelogram, then area will bisect, right? So area will bisect. So that is the idea of that theorem. Okay, the video. So what is the last theorem? So if you're going to draw the BD diagonal, so it will bisect the area. So ABD area equals to BCD area. Okay, ne? Let's quickly move to the last theorem related to parallelogram, right? Let's quickly move to the last theorem related to parallelogram, right? I'm going to take A, B, C, D, and I'm going to draw the diagonals. Look at the diagonals. 1, 2, diagonals bisect each other. Diagonals bisect each other. So this one is very important and very simple theorem. So what is that one? In a parallelogram, diagonal bisect each other. In a parallelogram, diagonal bisect each other. Right, easy. So what are the theorems? Look at this one. What are the theorems, Patio? Right? Look at this one. What are the theorems? In a parallelogram, opposite sides are equal. Opposite sides are equal. Opposite sides are parallel. Opposite sides are parallel. Opposite angles are equal. Opposite angles are equal. Area bisect by the diagonal. Diagonal bisect each other. So theorem number 11, theorem number 12, theorem number 13, theorem number 14. Right? Theorem number can be different, right? No need to worry about the theorem number. Just try to understand what are the all theorems related to grade 10. So parallelogram part is done. But very important question type is there. Sometimes in exam, they will give you the quadrilateral. You need to prove that, yes, this is a quadrilateral. In that situation, you need to know what are the cases. So we can prove that one through the parallelogram. Let's quickly move to that one, right? Theorem number 11, 12, 13, and 14. Parallelogram theorems. Let's quickly move to the next one. Theorem. Now we are going to learn that what are the conditions should be satisfied for the parallelogram. What are the conditions should be satisfied for the parallelogram? If opposite sides of a quadrilateral are equal, if opposite sides are equal, so that means there is a quadrilateral, opposite sides are equal, then opposite sides are equal means that is a parallelogram. If opposite sides are equal, so that is a parallelogram. If opposite angles are equal, right? Look at this one. If opposite angles are equal, so opposite angles means this one equals to this one. So these two angles are equal. If opposite angles are equal, then this is a parallelogram. So what are the conditions? If you can prove opposite sides are equal, that is a parallelogram. If you can prove opposite angles are equal, that is a parallelogram. Third one, if you can prove that diagonal bisect each other, if you can prove that diagonal bisect each other, so this one equals to this one, so this one equals to this one. If you can prove that diagonal bisect each other, then it is a parallelogram. If you can prove that pair of parallel lines, if you can prove that pair of parallel lines, one pair, right? Parallel and equal. Pair of opposite sides are parallel and equal. Both should be satisfied for the one pair. Both should be satisfied for the one pair, right? Opposite sides are parallel and equal. So what are the conditions that you need to prove that onto the parallelogram? If opposite sides are equal, that is a parallelogram. If opposite angles are equal, that is a parallelogram. If diagonal bisect each other, that is a parallelogram. If the pair of opposite sides are parallel and equal, that is a parallelogram, right? So those are the conditions should be satisfied to prove a quadrilateral is a parallelogram. Sometimes in the exam they will be given prove this is a prove that one as the parallelogram. So you need to take in your mind, you need to keep that in your mind. So how to prove that quadrilateral is a parallelogram? You need to satisfy any other conditions, any of the condition within that four, right? So you can prove that. Okay, right? Then we can quickly move to the next theorem. So what is the theorem number? 15, 16, 17, 18, and 19. Theorem number 19, right? So this is the center O, and you can see this is the chord. If you are drawing perpendicular line to chord, perpendicular line to chord, a perpendicular line to chord, then chord bisects. Chord bisects. So that means A, B, I'm taking this one as C, right? If OCB equals to 90 degree, then AC equals to CB. AC equals to CB. OCB equals to 90 degree. If OCB equals to 90 degree, then AC equals to CB, right? A perpendicular line from the center, to chord, then chord will bisect it, right? So that is the theorem, very important theorem, question theorem number 19. Then we can move to the last theorems of the grade 10. So I'm quickly moving to the last theorems of the grade 10. Right. Let's quickly move to last theorems, angles, right? Angles in a circle. Angles in a circle, right? Look at this one, Lamai. Angles in a circle, right? Look at the starting point is same, ending point is same, so we need to touch the perimeter. If we are having these type of angles, so those two angles are equal. If you are having these kind of angles, so those two angles are equal. What is the theorem? What is the theorem? Angles, right? Same segment. Just quickly talk with me. What is the theorem, Padio? Yes, very good. Theorem, angles in the same segment. Angles in the same segment. Angles in the same segment. Those angles are equal. Those two angles are equal. These two angles are equals together, right? angles in same segment. Theorem number 21. This is the center. Angle at the center is twice angle at the perimeter. So that means if this one equals to 30, this one equals to 60. If this one equals to 40, this one equals to 80. If this one equals to 100, this one equals to 200. Angle at the center, this is the angle at the center, and this one is known as angle at the perimeter, right? Look at this one. So this angle is known as angle at the perimeter. Angle at the perimeter. This angle is known as, this is the center now, angle at the center. Angle at the center. So angle at the center is twice angle at the perimeter. That is the theorem. Angle at the center is twice angle at the perimeter. Angle at the perimeter, right? Angle at the perimeter, right? So that means I'm taking ABC, right? So we can write down AOB equals 2 times ACB. AOB equal 2 times ACB. That is the theorem. But the question is, right? Look at this one. But the question is, this is theorem number 21, right? I'm quickly moving to this one, right? Look at this one. Angle at the center is twice angle at the perimeter. 40 means, so we need to multiply by 2. This one equals to 80. Angle at the center, angle at the center, angle at the perimeter. If this one equals to 30, value of this angle equals to 60, double venom, right? Angle at the center and angle at the perimeter. Right. So if this one equals to 20, this angle equals to 40. This angle equals to 40. Angle at the center, angle at the center, this is the angle at the center. So I'm going to draw angle at the perimeter on the other side, like this. Then we need to take the reflex angle. Then we need to consider this angle. So if this one equals to 200, then value of this angle equals to 100. So those are the 4 stages of this theorem. Angle at the perimeter is twice angle at the center is twice angle at the perimeter. Angle at the center is twice angle at the perimeter. Angle at the center is twice angle at the perimeter. Right? So we can move to the last theorem. What is the last geometrical theorem related to grade 10? Lamai, this is the center at your right. Look at this one. This is the center. And this one is the diameter. If you are drawing angles on the diameter on the semicircle, so this one is known as semicircle, no? Angle at the semicircle equals to 90 degree. Angle at the semicircle equals to 90 degree. Angle at the semicircle equals to 90 degree, right? So what is the theorem? Angle in a semicircle. So if you are drawing any angles on the semicircle, all those angles are equals to 90 degree. All those angles are equals to 90 degree. Right? So I have explained all the theorems related to grade 10. So you can see that one on the figure, right? I have explained all those theorems related to grade 10. Just try to study those things before the exam. and try to get the highest mark for the term test, right? If you have any questions, Paddy, let me know so we can discuss that one. So those are all theorems related to grade 10 students, right? So just practice this one and try to think and try to do more questions for the geometry part. Then see you soon with the grade 11 part.